quite convenient. So we have the sketch of part of a curve C with this equation, and we have to find dy by dx, giving your answer in the simplest form. 2 marks only, shouldn't be too complicated. So what rule do you think we could use? Remember, we have learned a few rules for differentiation. It could be the chain rule, it could be the product rule, or the quotient rule. And sometimes you can decide just thinking, it cannot be quotient rule because I don't have a quotient. It cannot be product rule because it's not a product, so it must be chain rule. Yeah. So sometimes you don't see what it is, and you can say this is not, so it's the other. Yeah. So we have a function of a function, really. Yeah. We have a square root of something that is already a function with a derivative. So think that when we have a function of a function, we have like u to the power of a half. When we differentiate this, we have 1/2 u to the power of 1 less, and then the derivative of the function. We can think like that, yeah? And this is almost going to be the same. We have a function of a function, yeah? So please try to differentiate that. I think I'm going to do it in the next page. If not, we don't have space. So it's going to be dy by dx. I'm going to copy again the function 3. So my function is root of 3 plus 4e to the power of x squared. If I use the chain rule, as I say, is going to be 1/2 at the front, then the function, which is 3 plus 4e to the power of x squared to the power of 1 less, so minus 1/2, and I have to differentiate this function. So this was my u, and I have to differentiate that, yeah? So the derivative, this one doesn't give me derivative, this one is 4. And again, I have a function of a function, so I should use the chain rule again. So remember, e to the power of x squared, if I have, let's call e to the power of b, yeah? So when I differentiate this, I will have e to the power of b multiplied by b prime. So that's what I'm doing here. I have the 4, and then I have e to the power of x squared, and I multiply by the derivative of x squared, which is 2x. Yeah? It's kind of the chain rule twice. So I have 8x e to the power of x squared. So my derivative, this goes here. So all this is what I am adding in this bit. Ax e to the power of x squared. We can simplify very little. So we can simplify the 2 with the 4 and the 8 and not much more. Yeah. So e x squared, I'm going to write that all. Maybe we can write this in the denominator, but it really doesn't matter. Yeah. 3 plus 4e x squared. So that's my, that's my derivative. Yeah. So I have applied the chain rule twice, dy by dx. Yeah. Is clear? So remember this, the differentiation, the 13 differentiation questions is going to be with the chain rule, product rule, or the quotient rule. Yeah. Then it says the point P with coordinate alpha lies on C. So this point is alpha something. Given that the tangent to C at P passed through the origin, so this one passed the origin, so that x equals alpha is a solution of this equation. So we have to find an equation that gives us the x coordinate of this point. And the particular thing of this point is the tangent past the 0, 0. So that's what they are telling us, because I think it's the writing is complicated with just, this is a bit confusing. So we are trying to find a point such as the tangent past the 0, 0. We have already differentiated our function, and we can use that. Any thoughts? There is probably more than one way of doing it. Just think what I know about this tangent. Yeah, so if I have the tangent, the coordinates of this point are going to be x and the y is going to be root of 3 plus 4ex squared. Those are the coordinates of that point, yeah, or alpha if you prefer to call it alpha. We know the gradient is the one that we just did. And we know the gradient if the line passes the origin, yeah? So I can find this gradient doing changing y divided by changing x. So I can make my derivative equal to the gradient of the line. Without finding the line, I could write the equation of the line, but I don't need to, yeah? So the gradient of this line is going to be this divided by this. So the change in y divided by the change in x. And that gradient is going to be equal to the gradient that I found before. Yeah, it's a way of doing it. So the gradient of the line, that was root 3 plus 4ex squared, just because it passed the origin at that point. I'm just using the line and ignoring the curve. Yeah, so I'm ignoring the derivative. I'm just using the coordinates of this point to find the gradient of this particular line. Divided by x, so changing y divided by changing x, the gradient must be equal to the derivative. And that's what I'm going to solve. You're going to see that this equation, when we rearrange a bit, is going to be the one that they ask us, yeah? I can cross multiply, so the root is gone, and I have 3 plus 4ex squared, and on the right I have 4x squared e to the power of x squared. And if we look at this equation, it's the same, just everything in one side, yeah? So 4x squared, just organizing. So 4x squared ex squared minus 4ex squared minus 3 equals to 0. Yeah, it's simpler than it looks like. So now that you see it, I think I had to look for this one. And the first time I did it, I think I have to look at the mark scheme because I was a bit confused with. I didn't know if writing the equation of the line, passing the origin, and the point, and I was a bit confused. Yeah. But it's simpler than it looks like. Then, hence, so that alpha, so the solution to this equation, lies between 1 and 2. I think none of you have seen numerical methods with me. I hope you have seen them at the school. But if you haven't, when you have a function and you have a root in between two values, so in between 1 and 2, I have a root of my function. That means that the function crosses the x-axis. That's a root, yeah? So if I find f of 1 and f of 2, they are going to have different signs. So they could be positive and negative or negative and positive. And if that happens, it means that the graph cuts the x-axis if it's continuous. That is going to be continuous in all the questions, yeah? So how we find or how we show that there is a root in between 1 and 2, we are going to find this function for 1, this function for 2, and then we are going to check that they have different signs. Yeah? And if they have different signs, in between, I will have a 0. Yeah? So if we call that function fx, I'm going to do f of 1 and f of 2. So I'm going to call this fx. So what I'm going to do is f of 1, f of 2, check that they have different sign, and that's it. Yeah? So when x is 1, this is 4e minus 4e minus 3. So it's minus 3, smaller than 0. And when I have 2, I have something a bit longer. I get 652. If not, don't worry too much. Just the idea is the important thing, yeah? So negative value, positive value, as the function is continuous, because all these functions are continuous, I don't have asymptotes, then I have a root, yeah? So therefore, as the function, you should mention that the function is continuous, as fx is continuous, because if it's not continuous, there is a root between, so alpha is between 1 and 2. Alpha is between 1 and 2. Yeah, we can write it longer. Look what happens if I have an asymptote. So imagine I have this graph and I have an asymptote here. So these are my axes. And imagine this function is doing something like this and like this. Yeah, I may have that 1 is positive, 2 is negative, and I don't have a root. Yeah. So if it's not continuous, nobody assures you, sorry, that you have a root in the middle. You can have an asymptote. Yeah. So it's important that you mention that it's continuous. It's going to be continuous always, but mention in your answer. Yeah. Is clear even for those who haven't seen this before? Yeah. More. Then, so that the equation in part B can be written in this form. We are going to iterate it now. It's simpler than it looks like. So we have to try to write this formula this way. It's not making x the subject necessarily because you have x squared as well here. So what you're trying is just to reorganize. You have an x squared here, which means the x that you're making the subject is just this one, and this e to the power of x squared are in the other side. Yeah, so what they have done is to make this x the subject, not all x. Yeah, so if we make this x the subject, let me do it. So we have the if we make that x squared the subject, so I'm going to use this one. I have 4e to the power of x squared plus 3, and then divided by 4e to the power of x squared. Yeah, I'm just using this one. I'm making x squared the subject. So this goes positive the other side and divide by 4e to the power of x squared. And I'm going to do the square root. How they write? They put this together. So they divide the fraction. When we divide the fraction, we have 4e squared. 4e squared is 1, and then plus 3/4. No, I'm going to leave the 4. Sorry, I'm going to leave the 4 outside. So 1/4 because they have it outside, and then I'm going to divide the 4e squared plus 3 by ex squared. So I have 1/4 4 plus 3e to the power of minus x squared. Yeah, so I'm dividing this one by e squared, and I have 4, and this one by e squared, I have 3e to the power of minus x squared. And now I'm going to do the square root. So x is going to be the square root of all that. The 1/4 can go outside, and then I have the square root of everything else. And that's the formula that they are giving me. Yeah, so I have the 1/2 and the square root where they have divided by e to the power of x squared. Yeah. Is it clear? It's just a bit of working out and try to make the things, try to write the expression in the same way that they have. Is it clear? Any question? No? Okay. That is going to help us to iterate and find the root that we need. Yeah, because we know that alpha is the solution to this equation, and maybe is a difficult equation that we don't know how to solve it. That's where we use numerical methods. And numerical methods means that we are going to try values of x until we find the actual answer. We know we have a root between 1 and 2. So they are going to ask us start with one value between 1 and 2. Using this iteration formula. And look, here they say with x1 equals to 1, use the iteration formula to find to 4 decimal places x3 and alpha. Did you know how to use iteration formulae in the calculator? What you should do is you are going to write the first value in the calculator and click equal. So that's an answer. So you just click 1 equal, just 1 equal. So that's going to be your next answer. And then you're going to write the formula, and every time it says xn, you're going to use the ans key. So you're going to write this formula in your calculator as best as you can with the square root, with the fractions, whatever you need. And instead of xn, you're going to write ans. Yeah, so please type the formula. Don't delete the 1, so you can have clicked 1 equal, and now you type the formula. Where it says xn, you're going to type ans. And when you click now equal, what the formula is going to do is substitute your previous answer, that was 1, and it gives you the next value, so x2, which is 1.129561. That for 4 decimal places is going to be 96. Yeah, so I'm going to write here 96 to 4 decimal places. If you click equal again without doing anything else, the calculator is going to substitute what you wrote as ans by this new number. And it gives you x3, which is 10997, 1 something. To 4 decimal places is that one. Sorry, that doesn't look. 099997. Yeah. If you click ans again and ans again, we will keep getting x4, x5, x6. When they ask me to find alpha, that means I'm going to keep clicking until the number doesn't change, up to 5 decimal places, not just 4, because the 5 sometimes can change going up, and then the number will round up. So just click equal a few times until you see the thing doesn't change. Yeah. And if you do that, I get alpha 1.1051 to 4 decimal places. Yeah, that doesn't change. So that's the idea. We know we have a root between 1 and 2 because we just proved in part C. We try to rearrange the formula that we have to solve. And what we are going to do is to just chuck values in until we get closer and closer and closer to our root, until it doesn't change up to a certain amount of decimals. Yeah, that's how we iterate. And it's a very clever way of solving equations that we maybe don't know how to solve algebraically. Is it clear? All of you? Okay. Did you get the same value? Okay, amazing. Yeah, okay, it's that value. Perfect. So let me do another one. We are going to do now hypothesis testing. Remember, hypothesis testing, binomial in year 12, normal and correlation in year 13, but you're going to have one or more. Manufacturers of miracle root claim that as long as the instructions are followed, 80% of cuttings taken from Christmas trees will grow roots and develop into healthy new trees. I cannot say that. Horticulturist suspects that this claim is optimistic, and he takes 500 cuttings, and after carefully following the manufacturer's instructions, finds that 380 of them develop roots into healthy young trees. Carry out a hypothesis test, 1% significant level, to determine whether there is evidence to suggest that the claim is optimistic. Is this a binomial, a normal, a correlation? What type of question is it? I only have 3 options for them. And again, you can think just discarding. Is this a normal distribution? Surely not. They would give me the mean and the standard deviation. And it's not correlation because I'm not checking if there is a correlation between them. So it's going to be a binomial. And I have something that is repeated and it will be success or not success. So 80% of cuttings is my probability. So P is 0.8. That's the probability of they grow into a healthy tree or a grown-up tree. Then N is 500 cuttings. So this is my N. So my binomial is 500, 0.8. After carefully following the manifest, 380 out of the 500 developed roots. So that's my observed value in my sample, yeah? Which means my H0, who can tell me my H0? Luna, tell me.
The H0 probability is equal to 0.8.
Exactly. And now, if it's optimistic, so we are checking if that's optimistic. So what do you think I'm going to write for P1, for H1? Greater, smaller, or different? Lunel, what do you think?
Less than, like
Less,
smaller than 0.8.
less than 0.8, because we think, no, less than? No, if it's optimistic, we can check either. Yeah, if it's optimistic, the probability will be less than that. Yeah, exactly, smaller than. So we are going to assume that this is true. So we have a binomial 500 because we are checking 500 cuts, and the probability should be 0.8. It's a one-tailed test, and remember, I have two ways of doing it: with the critical region, or just checking the probability of the observed value, which is this one. So let's going to do the shortest one. Probability of x being smaller or equal. If I'm checking small, I'm going to have smaller or equal. If I have greater, I'm going to check greater or equal. Yeah? Smaller or equal than 380. I'm going to check if it's smaller or equal than the significant level. So calculator, we go to the binomial CD, remember? Binomial CD, because it's cumulative, I have the smaller or equal. X is 380, N is 500, and P is 0.8. And I get 0.016. My significant level is 0.01, which means this one is greater than my significant level. If it's greater, that means it's likely, or at least a bit likely to happen. Yeah, if it's likely to happen, that is 380. When this is the probability, I'm going to assume that this one is true. Yeah, so I'm going to assume that H0 is true. So I'm going to accept H0. Yeah, if it's smaller, that means the probability of having 380 when this is true, because we are assuming this is true. If not, we cannot use the calculator. Yeah, we are assuming this one is true. If the probability is smaller than the significant level, that means the probability is tiny, tiny, tiny. So if the probability of this being tiny, tiny is true, we are going to reject and accept the other. Yeah, so that's what we are comparing. So what should be my conclusion? Do you remember what should I write? We are accepting this one. Tell me, Sammy.
Would you say you accept H0 because there's insufficient evidence to suggest that they'll develop into healthy young trees?
Exactly. So what I'm going to say is that there is insufficient evidence, or there is not enough evidence to support that the manufacturer's claim is optimistic. That's what you are testing, really. The other way of doing it is with the critical regions. I'm going to show you how to find the critical region because in some questions we'll ask you to find the critical region. Yeah, so let's going to find the critical region. Remember, the critical region is, I'm going to find a value that is just smaller than the significant level. So remember my binomial, the probabilities are doing something like this. Yeah, if I have 500 cats and 80% of them are healthy, yeah, or growing, that means like I would expect something like 400 good heal, yeah, or good grow. And I'm just checking which one will be too late, because I'm checking the left tail. I'm just searching for a number here that says, if I have less than this, I'm going to reject because they are too little, yeah? How do I find this value? If I have the tables, I can use the tables. That happens in the Excel questions, but the tables have up to n50. So we are not going to find 500. Yeah, there are only a few tables. So we are going to use the calculator. We are going to put values here until we find the first one that is smaller than 0.01. Yeah. So if you go again to the binomial, you are going to change the values of x until you find the first one that is smaller than 0.01. We know that this is very close to 0.01, so it will be very close to this. Yeah, 380. Let's say I'm going to try with 300. Very close to 380. Okay, so when this value is 378, my probability is 0.009. So it's just smaller than the significant level. So that means that my critical region is x smaller or equal to 378. So if I get 378 or less, I'm going to reject my hypothesis 0. But my value is just above, so it's not in the critical region because it's 380. Yeah, so 380 is not in critical region. Just is not in critical region. So if it's not in critical region, I have to accept 80. Yeah, critical region is when we reject because it's too to the sides or too high or too low. Yeah, does it make sense? Yeah. And this is how we do the hypothesis test for binomial. When you have correlation, you are going to use this one only. So we are not going to use this method for correlation. We are going to use this one only. Yeah. And for normal distribution, we can use both things. More. Let me show you this one. We can use another iteration. Well, it's another iteration. Let's go into do it. So Joe used the Newton-Raphson method to try to solve this equation. This is a numerical method question again. Newton-Raphson is a method of iteration that has a particular formula. The formula is in the formula booklets, so I can show you. In numerical methods, you have the trapezium rule and the Newton-Raphson. Yeah. So the formula is telling you that each value is the previous one minus the function divided by the derivative. So we always have to find, right, the function and the derivative. It's very simple to use. So in this case, they ask us to show that this is the Newton-Raphson formula. It's just one mark. So I have xn minus the function, which is this one, divided by the derivative. That's the only thing that you are doing, differentiating this function. So this is fx. Yeah, this is fx. And if you differentiate this function, you have 3x squared minus 6x minus 10. And that's the Newton-Raphson formula. So it cannot be easier. Then the questions maybe are not easier, but the formula is easy. Yeah. Joe uses, so what you have to do for this part, it will be just write that f is this function and f prime is this function. Yeah. Joe uses x equals 0 in this formula to find a root and obtains the following values. So this one is x1 and this one is x2. Joe states that the root must be between 3.92 to 2 decimal places, and argues that it's because both x1 and x2 will begin by 3.92. Just 2 iterations. Yeah. If you have done a few iteration questions, you see that sometimes the numbers oscillates, and then one of the decimals maybe goes up because the number, the next one has gone a bit up. Yeah, so the numbers are not, it's rare that they don't change after just 2 iterations. So it's quite early to say. What would you answer? So it says, comment on the validity of Joe's argument. So the root must be 3.92 to 2 decimal places. And look here. if I round to 2 decimal places, this one would be 9.3, this one will be 9.2, but the next one could be 9.3 again, maybe. Yeah, sometimes we are oscillating, and it's not going to be for sure 3.92. Yeah, so you have to say, let me show you what they say in the mark scheme, but something like the decimals still can change. This can go up to 3.93. Yeah, so let me read what they say. Not valid, the sequence may decrease further, far enough to change the first 3 figures. Yeah, decrease further or increase. Yeah, so could you use the sign change argument to show that Joe's statement is correct. So we say that it might not be correct because the decimals can change, but he's correct, and now we are going to prove it, but well, yeah, not just saying, oh, this is surely this. Do you know how to do this? You haven't done, have you done numerical methods? So Lionel, you haven't. Rex, you have? Yes? Tabitha, Harriet, something, have you been, James, have you seen numerical methods? No. Okay. Then I hope you understand the question. Okay. What we are going to think is, again, do you remember that reasoning that we did before when I say we are going to prove that we have a root between 1 and 2? Yeah. If we have a change of sign. So if we have that f of 1 is positive and the other is negative. This is going to be the same. So what we want to do is to see an interval that when I round to 2 decimal places is going to round to 3.92. What is going to be that interval? So that interval that is going to round to 3.92 to 2 decimal places is 3.915 and 3.125. All the numbers in between, if I round to 2 decimal places, all of them are going to round to 3.92. Yeah? Yes? All of you. So if I am able to find that f of this value is positive and this one is negative, or the other way around, that means I have a root in this interval that when I round to 2 decimal places is going to be 3.92. So that's the way of showing these questions. Yeah. So I'm going to find f of this value, f of this value, and then I'm going to see if there is a change of sign. Yeah. So, and my function. So we are trying to find a root for this equation. Yeah. So what I'm going to substitute, I think maybe it's not even worth it because it takes ages to substitute the numbers. But let me show you. F of this one, so 3.915 is minus, and f of 3.925 is positive. Yeah. So we have that the 15 is negative and the 25 is positive. As we have a change of sign, we have a root in that interval. Yeah. That is going to be rounded to 3.92. So it's similar to the reasoning that we did with the 1 and the 2, but now we are just deciding what is our root to 2 decimal places. Yes. This is the graph of the function that we are trying to find the roots. Yeah, we have roots here, here, and here. And the graph shows that there is a root between 2 and 3. Between 2 and 3, so this is 1, 2, 3, is this root here. Yeah, so this is 1, 2, 3. And we are talking about this root. We have a root in between the 2 and the 3. Yeah, because we have the graph. And it says, Joe, so again, using the Newton-Raphson method, uses x equal 3 to attempt to find this point. Find x1, x2, and x3. So what we are going to do is the same that we did before. So we are going to type in the calculator 3 equal, so it stays as an answer, and then we are going to type the formula, this one, the Newton-Raphson, and every time it says xn, we are going to write answer, so we can iterate. Yeah. So let's going to do that. We are going to start, we say, with 3, no? So 3 equal, and then we type the formula with ands every time we have that, yeah? So once you have the formula, you click equal and you get the next value. I get -2. So when x0 is 3, x1 is -2, and they ask me x3, yeah? No, x2 and x3, sorry. I don't know if you have time to type the formula. I just don't want to delete that. Did you have time to type the formula? Okay, so x2 is -50, so x2 is minus 3.7857, and x3 is minus 3.1683. So you see, we're trying to look a root for a root that is kind of 2 point something, and we are starting to go farther away from that. So we are going to the -3, which is really this root. Yeah. So we are trying to use the method to start to find this root. This is a very curious question. But instead of this one, our method is taking us towards the -3 point something, so towards the wrong root. And it says, explain why the Newton-Raphson method fails to give the required root in this case. So it's still working to give us a root, but not the one that we want between 2 and 3. If you haven't done numerical methods and Newton-Raphson, you don't know. But what happens with the Newton-Raphson is, look at the formula in general. Yeah, we have a derivative in the denominator. When the derivative is 0, this is not even defined. And when it's close to 0, it's going to do strange things. So here we have started with 3, and 3 is a minimum or around a minimum. Yeah, when the value that we substitute in the Newton-Raphson is close to a stationary point, so maximum or minimum, the method is not going to work. Yeah, it's not going to go towards the root. It's going to go somewhere else. Yeah, when you see Newton-Raphson method, you will see why. Yeah, we are working with the tangent, and the tangent will cut in another point, and then the tangent will be in another point, and there is a reason. I don't want to complicate it if you haven't seen numerical methods. But Newton-Raphson, remember, you cannot start with a point that is close to a stationary point because it won't work. Yeah. So that's the reason in this case. The 3 is close to a stationary point. And then explain why Joe should do, or what he should do to find the root of this equation between 2 and 3. We know it's between 2 and 3. We know we shouldn't use 3 because it's too close to a stationary point. What number we should use to start the iteration? The 2. Yeah, we could start with any number. It doesn't need to be the size of the interval. It doesn't need to be 2 or 3. It could be 2.5 to 3.5. Yeah, it doesn't matter. But it could be 2 would be a better option. Yeah, if that makes sense. So we should use x0 equal to 2. Yeah. Does it make sense? More or less? I hope I haven't confused you with you will cover this, and you will cover this with me as well. So, any question? No? Okay, let me show you another one that is no numerical methods. You haven't probably covered differential equations yet if you haven't covered numerical methods. Have you covered differential equations? Harriet, you have. Lunel, you haven't. Some of you. Okay, Lunel, you're going to be fine, I think. Sandy, I hope you are fine because it's easier than the numerical methods, or at least you don't need to know something. In a chemical reaction, compound B is formed from compound A and other compounds. The mass of B at time t is x kilograms. So mass of B, so we have B has x kilograms. The total mass of A and B is always 1 kilogram. So both together is 1 kilogram, which means A, we can write that is 1 minus x. Yeah, if both together add up to 1, if one is x, the other one is going to be 1 minus x. Sadik formulates a simple model for the reaction in which the rate of which the mass of B increases is proportional to the product of the masses of A and B. This is nothing to do with A levels. You have done these proportional models before, yeah? So the mass of B increases is proportional to the product of the masses of A and B. The rate of change at which the mass of B changes is proportional to the product of A and B. And they are asking me, so that the model can be written this way. The rate of change of B is going to be dx by dt. Remember, rate of change is derivative with respect to the time. And we know this is proportional. Remember that first thing that you used to do? To the product of the masses. The mass of one is x, the mass of the other is 1 minus x. How do I write that they are proportional and is increasing? With a positive constant. So I'm going to write that dx by dt is a constant and x 1 minus x. That's what they are saying, and you have done this before. Not maybe with rate of change, but something proportional to something. You know how to write that. So this is the equation. Yeah, k is a constant. And it's positive because we know it's increasing. Yeah, the mass increases. If not, that constant will be negative. Is clear so far? Rate of change, remember, is how something changes with the time. So if it's the rate of change of the area, it will be dA by dt. If it's x, dx by dt. Yeah, just that. Then initially, the mass of B is 0.2 kilograms. So x is 0.2 when t is 0. Solve the differential equation expressing x in terms of k and t. To solve differential equations, the only thing I'm going to do is to separate my letters. So in this case, I have x and t. Okay, my two variables, the ones dx by dt. I'm going to separate dx in one side, dt in the other one. And I'm going to integrate. So let me show you because it's very intuitive, so it's not difficult. So I have to solve this differential equation, which means I'm going to put all the x's in one side and all the t's in the other. And the k doesn't matter. I can leave it anywhere. So I'm going to have dx on the left divided by x and 1 minus x. And in the other side, I'm going to leave the k, for example, and write dt. Yeah, so all the x's in one side, all the t is in the other. If I have more t's, imagine here I have, I don't know, a t squared. This will stay with the t because I'm going to integrate one side in t and the other side in x. I'm going to integrate now. Yeah, this one in x, this one in t. How do you think I can integrate this one? I know we haven't done integration yet, but all of you have done integration at the school, I think. How do you think I can integrate that one? Anyone? Please tell me if you think you know. How would you integrate that one? Harriet, tell me.
This is just a guess, but couldn't you just like times the x in and then do it like x to the -2 minus x to the -1 and then just integrate it normally?
Like this?
Yeah. Yeah.
You cannot bring, that would bring each of the x's independently up. So you cannot do that because it's not the same that x minus x squared to the power of -1. So if I bring that whole thing to the numerator, it will be the whole thing to the power of -1, and this is not the same that x to the power of -1 minus x to the power of -2.
Okay.
That doesn't make sense. The
Yeah,
same that a plus b squared is not a squared plus b
Yeah,
squared or cubed. Yeah. So we cannot do that. We
Okay.
can multiply, but I don't think it's going to help. There is a better way, no? Because okay, when you have algebraic fractions and you have to integrate them, a few things can happen. So if I have the derivative in the numerator and the function in the denominator, is going to be ln. Yeah. If not, what else I can try? We can divide. So, Sandy, what can I try?
Sorry, I don't know at all, but could it be partial fractions?
Yes, I'm going to split in partial fractions because then each of them will be what? Do you know what they will when I substitute, when I write partial fractions?
Sorry, what's the question?
So when I integrate the partial fractions are going to be what type of integral? What is this integral?
No, I'm not sure. Just ln.
Is ln.
Oh
Yeah.
yeah.
Because remember the derivative of ln is 1 over x. So when we have, we don't have the numerator is the derivative of the denominator, and we cannot divide because sometimes I have polynomials and I can divide. The best thing that you can do is split in partial fractions because then becomes simpler integrals that all of them are going to be ln. Yeah, each of them. So let's go into write quickly. Split in partial fractions. I have a 1 minus x plus b x, and then divided by the same. I substitute the x by 1, for example. If I substitute the x by 1, I'm comparing this with all these, yeah, to find a and b. When x is 1, the left is still 1, and the right, this bit is 0, and I have b times 1, so b is 1 already. And when I substitute the x by 0, when I substitute the x by 0, this is 0, this is a, and this is 1. So 1 equals to a. Yeah. So I have my a and my b, which means this integral on the left is the integral of 1 over x plus 1 over 1 minus x. Yeah. I think I'm going to write it here so we keep it. A and b are 1, both of them. So let me write. This integral is 1 over x plus 1 over 1 minus x dx equals to integral of k dt. Integral of 1 over x is ln x. Integral of 1 over 1 minus x is going to be ln of 1 minus x. By the derivative of 1 minus x is minus 1. So it's going to change my sign, yeah? This is going to be a minus instead of a plus. Ln 1 minus x, yeah? Instead of plus, minus, because the derivative of this one is minus 1 over 1 minus x, yeah? And then in the right-hand side, the integral of k with respect to t, so if we integrate it in t, is going to be kt. And now I can add my constant of integration, yeah? I'm going to add it in just one of the sides. I don't need to add it into. So they say, solve the differential equation expressing x in terms of k and t. Yeah, x in terms of a and t. So we don't want the logarithms. What can I do with the logarithms? I can put them together. I'm just solving. I just need to make x the subject. Yeah. So how can we read out of the logarithms? If I have logarithm of something equal to something else, and then take e to the power. Yeah. So we can do that. Sandy, tell me. Would you answer the question?
I was just gonna say, yeah, you take e on both sides. Sorry.
Exactly, in both sides. So can you help me to put these logarithms together?
Yeah. You take e, and then you take e on both sides. So then the right side would be e to the kt plus c.
Okay, but what can I do to put these logs together yet? Because there are two logs. I need one log of something.
Oh, can you divide them?
Yeah, exactly. 1 over 1 minus x. And then this is kt plus c. And now is when I take e. So x plus 1 minus x is going to be equal to e kt plus c, as some people say. Yeah, I just wanted to do like a one step in between. So I put these logarithms together. Remember, ln minus ln is the quotient. And now I can, the best way of working with an expression like this one, to find the constant and all that, is to think that this is e to the power of kt times e to the power of c. Yeah, when we multiply the powers, we add the indices. So this one here can be written like this. And what you're going to do is to call this, again, a constant. Yeah, because e to the power of c, when we don't know c, we can call it another c. It will be different, but it will be c, again, a constant. Let's call it a, so we don't get confused, a. Yeah, so your model would be x divided by 1 minus x is a e to the power of kt. Yeah. We need to make x the subject, and we have to use the information that they gave us before. So remember this information that they say initially the mass of B is 0.2. They tell us to find the constant of integration. We can find it here straight when we integrate. We can find it here. We can find it here. We can find it here. It doesn't matter. Maybe you get different constant of integration, but then when you put the expression at the end, it's going to be the same constant. Yeah. So when t is 0, x is 0.2. So when t is 0, it's going to substitute that. When t is 0, x is 0.2. So if I substitute that in the formula that I just found, that is this one, and then I make x the subject, then I have it. Yeah. So you see, integrate differential equations is not difficult. Just separate variables and integrate. So what is difficult sometimes is just integrate. So if I substitute the values, I have 0.2 divided by 1 minus 0.2 is 0.8 is equal to a. E to the power of 0 is 1, yeah, a. So my constant a is 1/4. I just simplified, yeah. So I have that x divided by 1 minus x is 1/4 e to the power of kt. And I'm going to make now x the subject, yeah. For that, I'm going to multiply. So I have x. I'm going to cross multiply. So the 4 goes to the left and the denominator to the right, yeah. Is ekt 1 minus x, all in brackets because the whole denominator is multiplying. So I have 4x. Please, if you don't see any of the steps, you tell me, yeah? Minus ekt x. All the x's in one side. So 4x minus plus ktx is kt. Factorize the x, 4 plus a. And then we divide. Yeah, so x is going to be ekt divided by 4 plus ekt. Yeah. So I found a, substituting the information that they give me. I have this expression and I have to make x the subject. To make x the subject, I want x multiplied by something equal to something, so I can divide. And that's what I did, yeah? So I cross multiply this. I expand this bracket. I bring this x together with the other x. I factorize this x, and then I have the right hand divided by all that multiplying the x, yeah? And that's x in terms of t. That's what they're asking me, yeah? I have integrated my differential equations. I've substituted to find the constant of integration, and that's my expression, yeah? So this is the amount of b when the time passes. And now that I have the model, well, still I don't have k, so they are going to give me more information to find k, and then maybe something to substitute in. So after 50 minutes, the mass of B is 0.9. Yeah, so in this one, I have to express x in terms of k and t. Now we have to find k. So it's like they give me more information to find k. What I'm going to do? Substitute this information. 15 minutes when t is 15, k, x is 0.9. We have to find k to 3 significant figures. So please, can you find it? Because I feel that I'm doing everything today. It's because I think you haven't covered part of this content. It's like the end of the end. So when t is 15, x is 0.9. When t is 15, x is 0.9. I have to substitute here and find k. Yeah, they give me that information precisely to find k. So if you substitute, you have 0.9 e to the power of 15 k, 15 k again. How am I going to find the k? What can I do to find the k? I'm going to reorganize my equation until I have E15K equals to something, so I can take lengths, yeah? So let's going to do that. I'm going to multiply 0.9 times 4 E15K, E15K, yeah? Expand the brackets. Bring all the e's together and everything on the other side. And once I have e to the power of something equal to something else, I can take lengths, yeah? So k is length 36 divided by 15. Some questions will ask you the exact value, and then you're going to leave it here. In this one, they ask 2, 3 significant figures. Yeah. So we just find that value, and we give 3 significant figures. So 3, 2, 3, 8, 9. Yeah. You see how we are going to use a lot of logarithms and exponentials without having a topic in year 13 about logarithms and exponentials. Yeah. So you have to be able to work with exponentials, and like here with logarithms, substitute them, solve them, eliminate them, and all that. So that's our k. And then they ask, find the mass of B after 30 minutes. What are they asking me? To find what when what is what? Who can tell me? I now have the model completely, yeah? Because I have this expression, and now I know k. So I know that x is e to the power of 0.239 t. So what are they asking me? Tabitha, what are they asking me? Look at the system.
Are they asking you to substitute 30 in for t?
In the t, and find x, yeah? So I need to find x when t is 30. So I'm going to substitute t by 30 minutes. Careful with the units, yeah, because t is in minutes, but they could say after 1 hour, and then you have to change into minutes, don't substitute 1 hour, yeah. I get 0.9969 something else, yeah. And remember, they both add up to 1 kilo. That means that at this time, this x B is almost all. So all of your thing is almost all B. So this is what they ask you. Yeah. And the last thing, and with this we finish, it says, explain what the model predicts for the mass of A. So A is the order, yeah, remaining for large values of T. So what happens for the mass of A that we don't know, but we know is 1 minus the mass of B. So maybe we can think for B and then decide for A, yeah? When T increases, what are we seeing that happens here? So we are getting, look, when T was 0, what was it when T was 0? When T was 0, mass of B was 0.2. 15 minutes after was 0.9. 30 minutes after was 0.9966. So the mass of B, you see, is growing very quickly, exponentially. So what is happening with the mass of A? If they add up to 1, the mass of A is going to be decreasing. So at one point will be almost 0. If this one is almost 1, the other one will be almost 0. Yeah. So with time, mass of A is going to almost disappear. Yeah. It doesn't make sense. So these questions are a bit complicated, I know, but it's you have to do them because they are all exam questions, and you can find something similar. Okay. Any question? No? Okay, see some of you at 3:30 and some of you next week, yeah? Enjoy the rest of the evening.
Thank you.
Bye.
Thanks, Mans.
Thank